Yes. Good afternoon to you once again. We are moving to calculus tutorial 3. Okay. That is also it's about more of about what we have done already, but just that this one they are more applicable at the tertiary levels. Those at the technical universities and others, it will be very much beneficial to you more than I think the SHS and other professional courses. But it is still on the calculus. Now, you know that if I have, let's say, sine x and I differentiate it, I'm going to get cos x. And you know that if I differentiate cos x, it's going to be negative sine x. This and many more. I think if I differentiate tan x, then I'm going to get z square x and so on and so forth. I want you to note this. Okay. But if I differentiate en like this, I'll get the same thing. I'm going to explain. Okay. So without wasting time, let us see a typical example. We are saying that if y is equal to sine 3x, you should find dy dx. Over here, what is going to happen is that we are going to pick this and differentiate it. So it becomes, this one alone becomes what? 3, and this one changes to what? Cos 3x. Then you maintain this again. I'm repeating. This is y is equal to what? Sine 3x. Take this one, differentiate it. 3x. When you differentiate 3x, you got what? You got 3. Okay. Then when you differentiate sine, you get what? Cos. Then you maintain this again. Let's pick another one. If y is equal to cos 8x, then dy dx is equal to, here you differentiate the 8x, that will give you what? 8. But if you differentiate cos, you get negative sine, then you bring your 8x like this. In a nutshell, this one will be what? Negative 8 sine 8x. Now be very careful not to multiply this 8 by this 8. This 8 is a constant, but this is what do you call an angle, so take note of that. Exactly. Let's see other examples so that you look at it and see how you go about it. So if I have y is equal to cos 10x, what happens? You differentiate this 10. So dy dx is equal to, when you differentiate this 10, you get what? You get 10. Then when you differentiate cos, you get negative sine. So negative sine, but you maintain this 10x. So it becomes negative 10 sine 10x. That's it. Okay. Now let me see. I'm just piling up some of these things here. So let's see this. We'll be mixing them up a little bit because of now. What do you think will be your result if I have y is equal to x cubed sine x? How do you calculate dy dx? How do you calculate it? X cubed sine x. They say dy dx. Here you will see that here it is what? There are two functions. So we let what? U be equal to what? X cubed. Exactly. This x cubed is 1, and then the sine x is also another. So over here, du is like the product we were doing. Du dx is equal to what? 3 x squared. Exactly. Then V is equal to sine x. So dv dx is equal to what? Is equal to cos x. After doing that, then we say that dy dx is equal to what? Do you remember? U dv dx plus v du dx. Do you remember? When we are dealing with the product rule, this is one function, this is another function. So this is u is equal to the u dx is equal to this. V is equal to this one. The v dx is equal to this. So now, what is your u? You are slotting them in. Okay, you are slotting them in. So your u is what? What's your u? Your u is so dy dx equal to what is your u? Your u is s cubed. Okay, I'm repeating. This u is s cubed. U dividing the x. That is, you maintain the u, then you multiply by the differential of the other one. So u dividing the x is what? Is cos x plus v. V is what? Sine x. V du dx. That was what? 3x squared. Exactly. So over here, I'm going to get s cubed cos x plus 3 sine x. Okay. Sorry, I think I've mixed something here. So it's equal to 3 s squared sine x. Let me write it visibly. I'm saying that it's going to be s cubed cos x plus 3 s squared sine x. This is your result. Is that okay? When you work it, s plus 3s squared sine x. Now, let us see another example. Let's see another example. Here is example galore. Okay. If I have y is equal to s4 cos 2x, and I have to differentiate this. Once again, this one, we are having what? Two functions, okay? So we say that u is equal to what? x4. So du dx is equal to what? 4x cubed. Then v is equal to cos 2x. So the v dx, which is the second function, is equal to, if you differentiate cos, you get negatives, and so negative sine 2x. No, here there will be 2 here. It will be 2 negative sine 2x. Exactly. When you differentiate it, what are we going to have? It's going to be, let me pause here a little bit for a very quick. I'll come back right now. I'll come back right now. Yes, as I was saying, Forever Construction and Consultancies Limited, as I was saying, we have that short break. I'm saying that if you want piece of land, you can call them wherever you want the land to be. That is Piena or Dodoa or several areas, Suhum and what do you call in Samon. Several places they have lands over there. If you call them, they will be able to help you. Land which is free from litigation. Okay, a fast developing areas with roads demarcated and everything. That facility that will help you, that will make you very comfortable. So call Forever Construction and Consultancies Limited on 050-151-8355. Okay, if those of you watching me outside the country, okay, you are in overseas, you can call Forever Construction and Consultancies Limited. They sell, affordable, houses that will also be helping you. When you call them, they will also be helping you. Exactly. So their number is 055 4, 8, 9, 21, 43. Call and then engage them. Exactly. Thank you. So this is what we are having now. Okay. So this is what you're having now. So in effect, the formula is what? U divin dx plus v du dx. That will be your dy dx. Is that okay? Dy dx. So what is your u? What is your u? U is x to the power 4. Divin dx is what? Negative 2 sine 2x. Plus v. What is your v? What is your v? Your v is this. Cos 2x. V du dx. Then the differential of the u is what? Is 4x cubed. So if you have to rewrite it, I'm going to have negative 2 x4 sine 2x plus 4x cubed cos 2x. This is it. Okay, that's it. Now let's see more examples under that. Okay, let's see more examples under that. So as we do, let me check them so that we can be moving very, very fast. Indeed, I'll be having one here, and that is what you have in negative 4. Okay, that's good. Now let's see another one. Let's see another one. What's it? We are on calculus. Okay, calculus. That is we are still on differentiation. Okay. It involves a lot of trig functions and others. So let me see this one. Y is equal to 3x squared. Is it 3x squared? 3x cubed, sorry. 3x cubed sine 4x. They say we have to differentiate this. You can see that this one is having two functions. We have u is equal to what? 3x cubed. So du dx is equal to what? 9x squared, right? Then v is equal to sine 4x. I'm differentiating them separately. Then after that, we apply that rule. So the v dx is equal to, we differentiate this one. That will be what? 4. The differentiate sign becomes what? Cos 4x. So the formula is u, which is what? 3x cubed dividing the x, that's the differential of this, times what? 4 cos 4x, okay, plus v is what? Sine 4x, v du dx times what? 9x squared. So in effect, I'm going to get this 4 times this one, but not this. So it will be what? 12x cubed cos 4x. I'm repeating. 12, you extract this and this, but don't go here. 12x cubed cos 4x plus, don't multiply this by this. This is an angle, plus 9 x squared sine 4x. Is that okay? So that is that. So that is when you differentiate this, that's what you're going to get. All these are what? Are the product rules. Okay? So we are still on it, on and on. We are on calculus. Subscribe to Calendarman TV, okay? Calendarman TV. And then get all these updates free of charge. A lot of, I'll be treating matrices where what is transpose and others, cofactors and others. We are going to treat all of them. How to use matrices in solving problems. I think that we shall be treating it very soon, to solving simultaneous equations and others. Now let's look at this question, and if you can help me to identify it. We have y is equal to sine 2x plus 1. What kind of question is this? This is really function, okay? So we let u be equal to what? 2x plus 1. It means the u, the x will be equal to what? 2. Now, what is y? Y is equal to what? Sine u. Is that correct? Y is equal to sine u. So if y is equal to sine u, then how are we going to, go about it? Then it means dy du is equal to what? Is equal to what? Is equal to cos u. Am I right? Yes. It's equal to cos u. Therefore, if I'm to multiply the two functions, because this is a function of function, so I'm going to multiply it back and see what is going to happen. So we say that dy dx is equal to du dx times dy du. And what is du dx? Du dx is what? Is 2, right? And then dy du is what? Is cos u. So we have 2 cos, and we know u to be what? 2x plus 1. So that is the result if you differentiate it. Okay. If you differentiate, that's what we're going to have. Let's see another interesting one. Okay. We are solving problem. I hope you will follow. Here we make here u, then you substitute like that and you use the product rule. Okay. So here we are solving the problems undiscriminately. Okay. So that is for your information. Let us see another one. We are having, it says that if I have y is equal to e, okay, ax plus c. How do we differentiate this? You could see that this particular expression here, we have to call it u. So we let u be equal to what? Ax plus c. I'm repeating. After we shall use numbers and you understand. So let's see this after I will use numbers. Here is u now. So if I differentiate du dx is equal to what? We are differentiating this with respect to x. And when you work it out, I strongly believe, and by confirmation, I'm going to get a. Okay. Then y is equal to eu. Why eu? Because you say here is u. And if I differentiate this, dy du is going to what? It's going to be eu. That is, you differentiate this and it becomes 1. Then times this, and it's the same. Exactly. Why don't we use some number as a typical example? Let me see if I'll be able to get some. If y is equal to, where is it? E 3x plus 2. You say we should find the y dx. So what do? We let u be equal to what? 3x plus 2, right? So that du dx will be what? Du dx will be what? Check it for me. What is going to be the du dx? Du dx is going to be 3. That's the first step. Okay? And after you get the 3, then we are talking about, so right now we've spoken about, we say u is equal to, then we have differentiated this. And after that, can we say something about it? And y is equal to eu. Is that okay? So dy dx, is it eu? Let me cross check again. Dy dx is equal to what? It's equal to eu. Sorry, dy du is equal to du or eu. Therefore, dy dx, you have to multiply the the two functions, and what is it going to be? It's going to be du dx, which is 3, then eu. But we know u to be what? U to be this, so it is going to be 3e. 3e what? 3x plus 2. Carefully watch this one. You could see that he maintained this one, he just differentiated this one, and then maintained this one back. You are not getting the point. If I'm having, let's say, y is equal to e 7x plus 8. The trick is that differentiate this one. When you differentiate, you get 7. Then you maintain this again, 7x plus 8. That's the bottom line. I wanted you to get this one. This is just very clever so that we move, very fast as such. Okay. I hope you're okay. So those that involve that E and you are talking about it and you are working it, blah, 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 that is what you are going to get. So let's see if you'll be able to get another one and then we work it. Is that okay? Let me see. It says ln x is equal to that. Okay. Y is equal to. I'm trying to get a typical example, then we work it. I want those that involve the ln, okay? Those involving the ln. And the rule is that if I have ln x and I differentiate it, I'm going to get 1 over x. Take it from me. If you have ln x and you do what? You differentiate it, that is what you are going to get 1 over what? X. So I'm trying to see if I'll be able to get a typical example, then we work it. I'm trying to get one so that let me see. Oh. Okay. Now let's see this one. If I have y is equal to ln s cubed plus 1, then what we are going to do is that you let u be equal to what? S cubed plus 1. Let's see whether what we are saying is true. Then du dx, what will happen here? Check it carefully. Du dx, what is going to happen? We are going to get 3, what is it? We are going to get 3x squared, is that right? Yes, I think that is right here. So that's the du dx. So what about your y? Is your y? So and your y is equal to what? Ln u. And so dy du is equal to 1 over u. Are you okay? I should go back. I should go back. Here is ln this. And we have made this u. After that, we differentiated. But once you have put u here, it means y is ln u. And when you differentiate ln u, you get u. So now, after getting that, then what we are going to do is that, so we say that dy dx is equal to product of the differential, which is 3x squared times 1 over u. So subsequently, I'm going to get 3x squared over u. And what is your u? U is what? Is s cubed plus 1. So what is your observation here? You could see that in differentiating this ln, what happens? What happens? We differentiated this one over the original. You are not with me. This one was differentiated, divided by the original. So let me say that if I have, let's say, ln 5x squared plus, let's say, 2x, what do you think will be the result? after you finish, after working everything, I'm saying that you are going to differentiate this, and when you differentiate, you are going to get, so dy dx equals to differentiate this one. That got 10x plus 2 all over 5x squared plus 2x. It's as simple as that. I'm repeating. When you get me like this, differentiate this top one, put it at the top, then write the original, the denominator down. If that's the case, let's see this one. Ln 7x3 plus 1. What is going to be the dy dx? Assuming this is y. Dy dx is going to be what? Differentiate this. You get what? 21x squared. This one will go to 0. All over 7s cubed plus 1. That's what I'm saying. I'm repeating for the last time. Differentiate what? I said differentiate what? So here we differentiated this. We got 1. When you differentiate this, you got 1. Then you maintain the original. That's why we see it that way. Is that okay? I think I've made my point clearer. Is that okay? That is how it is. And let me see if I'll be able to get another. Now, let us see this one. I hope you're okay with the name. Just follow it, okay? If you listen to it and you don't understand, just play back, go back, and then play it, and you get it, okay? Play back and you get it. I'm saying that the lane, if I have lane, let's say 2x to the power 4, and they ask you to find dy dx, if here is, let's say y. What did I say? I say differentiate this. You get what? 8x3. Then maintain the original s4. So this one, I think this one can go half one. 4s cubed over x3. And when you work it out, you are going to get 4 over x or so, something like that. Okay. I think I've made my point clear. So if it is multiple choice, whatever you're doing. Now let's see this one. If y is equal to 5, sine this to the power x. They say we have to differentiate this. Now, look at this carefully. This power 5 is the same as y is equal to sine x to the power 5. So what is your observation? This is purely function of functions, okay? So here, as usual, we remember how we did the function of function. We said that we let what? U be equal to what? Sine x. So du dx was what? Was what? Cos x. Exactly. U dx was what? Cos x. Okay. Then, what is your y? Y is equal to what? Y is equal to what? U raised to power 5. So, dy dx is equal to what? 5u4. I'm repeating. Anytime we see power like this, the square is something like this, which has been written. Normally, we don't write the square whatever power outside, but for purpose of explanation and simplicity sake, that's why I've written this 5 outside there. And we pick this as our u, and we differentiated it, we got this one. Okay. Then we say if u is equal to, what is the figure? This. Then we put u there, this is what you're having now, as your y. Differentiate this one, and we got 5u4. So here, the first one is dy dx is equal to product of the differential. And we have what? Cos x times what? 5u4. So we have cos x. Remember that the 5 will come here. And here is your u4. And you know your u. So you have 5. What is your u? What is your u? U is sine x. Okay. So this is what you are having. And you should note that, so it becomes what? Already, so you have, but this one is not, oh no, this is a fraction, sorry. This is well, it is cos 5x. So you have 5 cos 5x. Then sine x. Don't change anything, okay? That is it. So is it what the original question of course? Let me check whether so I'm having let me check the figures again, whether something has gone wrong. I want to be very sure. I want to be very sure whether we are following the track. So this is that, okay? So you have what? We multiply the differential, and the differential here is what? 5 cos x u4. All right. So 5 cos. Let me check it again. So it looks as if I'm not getting it yet. Now, over here, let me repeat. We are multiplying the differential. And what is the first differential? The differential is, this one is what? The first one is what? Cos x, okay? Multiply by 5, u is what? 5 sine, sine 4. Because the x is this one, it's like this. So in the nutshell, I'm going to have 5 cos x sine 4x. Yes, I think this is how it's supposed to be. Sine raised to power 4x. That's it. It seems I mixed some figures over there, and I've now put it over there. Okay, or the cos x will come in however you want to do it. It's going to serve the same purpose. Okay, let me see if I can get additional example that we can look at. Okay, let me see. All right. Okay, I'm trying to get one or two from here. I think all right. Let's see this one. I think this one is a quotient rule. Let's see if we can deal with this one. This is a quotient rule approach. At least let's see this quotient rule. Let's see this quotient rule, and then we see one product. Then almost we bring to this to an end. Or we should see the product first. Okay. You know we have y is equal to x4 ln x. Here's it. So purely, this one is what? It's a product, because we have two different functions over here. So we let what? U equal to what? X4. So the U, the X is equal to what? 4x3. Okay. Then if V is equal to ln x, I've told you, the V, the X is equal to what? You differentiate, it becomes 1 over x. You differentiate this, then you maintain the down there. Therefore, the y, the x is equal to product of the differential, that is 4x cubed times 1 over x. 4x cubed times 1 over x. Let me see, it seems I wrote it somewhere and I'm trying to trace it back. 4x cubed times 1 over x. So in the nutshell, we're going to have a very interesting result from it. Exactly. That's it. So we have this, which is this and that. But it should be noted that here we have worked out this, and we say it is what? U the x, plus v the u what? The x, that's how it's supposed to be. So now, what is your u? U is your what? X4. Then the v the x is what? Times 1 over x. Plus v, what is the v? V is ln x. Du dx is what? 4x cubed. Alright? Is that not it? That is what it's supposed to be. So, in a nutshell, this one, the x will go into this. So we have what? S cubed plus 4s cubed, right? Ln x. This is the result. I'm going over. This expression that you see, it is having two distinct functions. This is one, this is another one. And you know, now we know how to differentiate this one. If u is equal to, then the u dx is equal to what? 4s cubed. Then ln x, just differentiate the what? This x, and to give you 1. Then maintain the original here. After that, then you say the formula is what? V the u dx, u the v dx, plus v the u dx, and we substituted inside, and that is the result that we have gotten. Let's see if you can look at one of the product rules. Then possibly we draw the curtains to a close. Is that okay? So that is that. So let's see. This one is a product, and when we are dealing with the product, look, nobody will come and tell you it is a product rule, but depending on how the arrangement is, if it is something over something, then you know that it is what? It is a quotient. Sorry, it's a quotient rule. Quotient and product. Okay, they sound a little bit, but interestingly, there are some difference in them. You have to observe and know as such. I'm just reminding you that you have to subscribe to the Calendar Man TV. You yourself, you have been able to, identify. You know that we are actually firing. We are firing from all angles. This is mathematics. This is calculus. You can listen to any, channel anywhere. But do the comparison and you see that, yes, this is really a total classroom, a complete classroom that we are delivering. We are giving you the information. You can listen, you can just follow us and pass your examination. That is it, a total classroom indeed. Okay, now let's look at this very interesting one, then we proceed aside. We are having y is equal to, am I talking too fast? If that's true, just, make sure that you move like that. Is that okay? So we have ex over cos x. This is purely a quotient. This is what? A quotient. And we are applying the quotient rule. And in applying the quotient rule, what is the u? U is equal to what? Ex. How do you differentiate this? So the u, the x, you differentiate this one, whenever you get put it in front here. It is 1ex, so it's the same as ex. Then v is equal to what? Cos x. So the v, the x, is equal to what? Negative sine x. That's for your information. Now that we've been able to establish this, what does the quotient rule tells us? The quotient rule, what does it tell us? It tells us what we are supposed to know simply because it is telling us. Is that okay? Yes, any question? No. So let's move on. Okay, at the moment, let's look at the formula. We say that the quotient rule says that dy dx is equal to what? It's equal to v du dx minus u dv dx 1 over what? V squared. Is that okay? Yes, 1 over v squared. If you have been able to get this far, then what is the problem again? It's a matter of just substituting the figures into it and you get your answer. Is that okay? Yes, any question? No. Wow. Let's move on. What is the vein? Where is your vein? Look at it and tell me the vein as you are in your various rooms. Those in America, those in whatever. Look at it. Where is the vein? The vein is here, okay? We have cos x. Okay? Then the u dx. Where is the u dx? Is your ex. Right? Minus u. Where is u? The u is the u is what? Is the ex. Then the vein dx is what? Negative sine x. Negative sine what? X. All over v squared. And where is the vein? The vein is cos x squared. So it means it's going to be like this. Now let's see if we can do some realignment. This is dy dx. So here we are going to have what? In fact, one can decide to say that it is cos x ex plus sin x ex. Why is it plus? Because minus minus turn to plus. Then cos square what? X. Okay. So that is that. Okay. Now, let me before we end. For now, I think that the calculus the differentiation, it goes to its application and others where if you have let's say distance, you can differentiate the distance to get velocity, and you can differentiate the velocity, which is the being respect to time, to get acceleration, and you put the values there. You can use it to be working certain unknown constant that we can be talking about. For now, we may not be able to hit more on the applications now, but what I'm saying is that very soon we'll be dealing with the integration. Okay, so when it is time for the integration, I strongly believe that you also get to know it. In the course of time, we shall be dealing with that. For now, you have to take this one and make sure you subscribe to the calendar month. More are coming your way. Okay, we shall be treating the quadratics, and then that I think the quadratics, we haven't treated it. We have been treating the logarithms and indices and others, and the plane geometries and the topics that are actually worrying you. You're going to deal with all of them. But let me repeat that before I take leave of you. Go and buy your land from the Forever Construction and Consultancies Limited. That is where you have a very secure land with actual demarcation of the rules and others with the facilities available. That will definitely be helping you. You can call the Forever Construction and Consultancies Limited on 050 151 8355, 050 151 8355, or 055 48 92 143. Their lands are litigation free. I've been promoting them on the television and the radio programs on several occasions, and I haven't had any challenges with from the customers reporting that why have you done that. So it means it is very good. That's why I'm also projecting and promoting them to make sure that you go there. And also the Ashton Senior High School, a secondary school that actually help to. They have a very very good record. Whether we have foreigners and others, so many different people coming to that place. And also that place too, you can call. If you are in SHS 1 or 2, you want to do remedial classes, then the best school that I'm recommending to you is the Ashton Senior High School. It is located at Medina, at the Atomic Junction there. You can call Ashton Senior High School on 020 89 85 488. Move the Ashton Topso and you will love it. Stay tuned and subscribe to Calendar Month. Make sure that you press the notification bell with more updates coming your way. Thank you very much for staying with me. Bye-bye.